All right, in this video, we're going to be talking about linear inequalities. So I guess first off, a linear inequality going back, we talked about linear equations, so that was y equals some number x plus 1. But inequalities, we're going to be talking about what if y is greater than 3x plus 1? Or what if y is less than 3x plus 1? Or what if it is greater than or equal to or less than or equal to? So inequalities, they're not going to have an equal sign. They're going to have a greater than, a less than, a greater than or equal to, or a less than or equal to sign. So that's what we're talking about when I'm saying linear inequalities. So identifying solutions of inequalities. So this tells us, or you need to tell whether the ordered pair is a solution of the inequality. So they give you a coordinate, like for letter A there, we have 7, 3. And I need to know if I plug in 7 in for x and 3 in for y, is y less than x minus 1? So let me rewrite this. Y less than x minus 1. So what you're going to be doing is plugging in 7 in for x, 3 in for y, and seeing if that inequality is true. So 3 in for y, I got 3. Is that less than 7 minus 1? Simplify both sides of the inequality. I have 3 is less than 7 minus 1 is 6. So is 3 less than 6? Yes. So this one is a solution. Or you can say yes. So remember the little signs where it opens up, that means that that is greater than. So 3 is less than 6 because 6 is bigger. If it's the other way around, we would say 3 is greater than 6. Going on to letter B, plugging in 4 in for x and 5 in for y, I have 5 is greater than 3 times 4 plus 2. Make sure to multiply first. 3 times 4 will give me a 12, so I got 5 greater than 12 plus 2. 12 plus 2 will give me a 14. And is 5 greater than 14? No, so this is not a solution. So doing just a couple more of these. For 1a, x value of 4, y value of 5, so is 5 less than 4 plus 1? And we have 5 is less than 5. Now 5 is equal to 5. 5 is not less than 5, so that is actually not a solution. And the next one here, we didn't talk about one that was greater than, so let's treat that as a greater than or equal to. So is 1, 1 for y greater than or equal to x minus 7? So greater than or equal to, so a couple different choices. Let's plug in 1 for both. So I have 1, is that greater than or equal to 1 minus 7? So is 1 greater than or equal to a negative 6? And yes, 1 is greater than 6. You can always think about temperature. If it's 1 degree outside, that's bigger than negative 6 below 0. So that is a solution. All right, so moving on to graphing inequalities. So this is kind of a picture that says a lot of information. So if you look at this little paragraph, when the inequality is written as y is less than or equal to or y is greater than or equal to, the points on the boundary line are solutions of the inequality, so the line is solid. So what we're going to be doing, I guess, is we're going to be making, when we're given an equation, a line, and then we're going to shade one side. Now, we can either shade the top or the bottom, and the line can either be solid or dotted. So this is what it's talking about. When it's greater than or equal to, or less than or equal to, you've got to make a solid line. Likewise, when it's just strictly less than or greater than, they're not solid, they are dashed. When the inequality is written as greater than or greater than or equal to, you shade above. And when it's less than or less than or equal to, you shade below. So this says a lot of information, but what I'm going to do is make a table that will simplify it down quite a bit. So we'll make a little 2 by 2 box. and I'm going to put in the symbols. So I have greater, greater than or equal to, less than, and less than or equal to. So if it doesn't have the line underneath, that is a dashed line. If it does have the line underneath, it's going to be a solid. So the top row, I'm going to draw a dashed line, and the bottom row, I'm going to draw a solid line. I like to think of it, if there is a solid line underneath, like this and this, that means I'm going to make a solid line. Now, the first column, greater than or greater than or equal to, I'm going to shade above. So it's bigger, since it's greater, so we're going to shade above. And if it's less than or equal to, we're going to shade below. So all we have to do is look at the inequality and which symbol is it, and that'll tell us whether to shade, give it a dashed line, solid line, or to shade above or below. So we'll take a look at a few examples, and you'll kind of see how this works. So just a few steps. Solve the inequality for y, get what y on one side by itself. Graph the boundary line, so use a solid or dashed, and then shade above or below. So that's pretty much what the steps are here. So for this first equation here, or inequality, we are solved for y. We have y by itself, so we're good there. And let me paste that little table here. So this is our table that we're going to use. And before we use the table, it's just like those linear equations when we use slope-intercept form. We have a point at -2. We're going to make another point going using the slope going up 2 and over 3. So there are 2 points. Now look at the symbol. So where does our symbol match up on the table? Well, that one's this one right here. So that means I'm going to make a dashed line going through those 2 points, and I'm going to shade above. So we'll shade above that line. So that means every single point in this region is a solution. So if you would plug in any of those x, y values for the coordinate, those would work. But the ones on the line will not work. So everything from just above the line and up will work. Taking a look at the next one here, we have, nope, I didn't skip. Y equals 2x plus 3. So again, what's my y-intercept? That's the 3. Plot my other point using slope. So I have a 2 over 1. So we'll go up 2 over 1. Again, let's take a look at our table. The symbol for this one is this guy right here, less than or equal to. So that means I'm going to make a solid line. Something like that. And I'm going to shade below. So everything down here below the line. So this means that every single point in this region and on the line, that's what the solid means, is a solution. So every single point there. If you would plug that in to the inequality, it would work out. So the next one here, we're going to start at -2 for a y-intercept. A slope of -1/4, so that means we're going to go down 1 and over 4 to right here. And I have greater than or equal to, so that means I'm going to make a solid line. And I'm going to shade above since it's greater than. If it's greater than, you can think it's taller or bigger or higher up. All right, so this one here is not solved for y, so we need to get y by itself on one side. So what we're going to do first is get rid of either the x term or the 2 term. Let's get rid of the x first. So let's add x to both sides. So we have y plus 2 on the left side, and that's less than or equal to x. And then what we're going to do is subtract 2 on both sides. So y is going to be less than or equal to x minus 2. So now we are solved for y. We can actually start graphing this. So we have y-intercept at -2. I have a slope of 1, or up 1 over 1. So go up 1 over 1. And I am less than or equal to, so we have a solid line. And since it is less than, I'm going to shade below that line. So another inequality we have here, we want to get y by itself on one side. So we got to get rid of that 5x term. So let's subtract 5x on both sides. So we have 4y less than or equal to negative 5x and then plus 8. We'll leave them separate because one's a number, one's an x term. And divide by 4. And when we divide by 4 on the left side, we need to divide by 4 on the right side in every single term. So we have y is less than or equal to negative 5 over 4, x, and then plus 2. So we have a y-intercept of positive 2. We're going to go down 5, 1, 2, 3, 4, 5, and over 4. And since we are less than or equal to, we have a solid line. And I'm going to shade below since it is less than. So all that stuff down there. We're going to see some problems where we're actually going to go the opposite way. We're going to see a graph, and we're going to derive a inequality out of it. So let me put this little table up here first off. Put that right there. So we're always going to start off with a y. So that can be like our step 1, just write y. And then we have to determine our sign. We want to know if it's greater than, less than, greater than or equal to, less than or equal to. Well, if you notice that we have a dashed line right there, and we are shading below. So which one is dashed and below? That's this one right here. That is less than. So y is less than. All right. We're going to have some number with the x and some number on the end. So remember our slope-intercept form is y equals mx plus b. I need to find what my slope is, what my y-intercept is. Well, the y-intercept's easy. This one is 2. So we'll put a plus 2 on the end. But now I just have to find what my slope is. So let's find another point on that little dotted line that goes through an exact coordinate. There's one right there. So we got to go down 1 and over 1, 2, 3. So that would be a slope of negative 1/3. And there is my graph there, or my inequality. If you ever want to double check your answer, just kind of go back and work the opposite way. So positive 2, I got to go down 1 over 3. Okay, that would give me that same graph. Okay, this one here, again, we start with a y. I have a solid line and it's shaded above, so that's a greater than or equal to. And I have a y-intercept of negative 2. So the negative 2 is going to go on the end. And let's find slope. So we have another point here, so we're going to go up 1, 2, 3, 4, 5, and over 1. So 5 over 1, or just a 5x. So there is my inequality. One more here. So we have y, and it's a solid line, and it's shaded above, so it's greater than or equal to. And I have a y-intercept of 5. And going from left to right, you can pick any 2 points here, but we have one here, and you can choose really any of these. But you notice that how on each one I'm going up 1 over 1, up 1 over 1, up 1 over 1. Or if you choose something like these two, you would go up 2 over 2. But anyway, you think about it, this will have a slope of 1. So you can think of it as a 1x, or all you really need is just an x. And that is my inequality for that one. All right, so the last one here, we got a little word problem. Jack is making punch with orange juice and pineapple juice. He can make at most 16 cups of punch. So we need to write an inequality to describe the situation. Well, let's designate the orange juice cups as x, in pineapple juice cups as y. So the inequality that we're going to have, and this is for letter A, is x plus y, and it's at most 16, so it has to be less than or equal to 16. So it can be under 16, but it can't be over, and it can be equal to. So that is our inequality. And let's graph that. So we need to, and this is for part B, solve for y. So we need to subtract x on both sides. So we have y equals negative x plus 16. Or sorry, not equals, less than or equal to. So we have a y-intercept of 16. We have a slope of negative 1, so down 1 over 1. So we go down 1 over 1 to about right here. And that's actually going to take us all the way to the x-intercept of 16. So there's my line. Now, I'm going to shade underneath because it is less than, and I made a solid line because it's less than or equal to. So everything down here is a possible combination of orange juice and pineapple juice that he can use. And everything on the line as well. So anything that you want to put in here, you can do. So for letter C, two possible combinations. Basically, just choose any points in this area. How about 6, 8? That would be one of them. I can make 6 cups of orange juice and 8 cups of pineapple juice. How about we choose one on the line? We can do 8, 8. I can do half and half. That'd be another one we can use.